So we have a process like this, correct? And then we change this process to this. In the previous process, average flow time was half a month or 15 days. We want to know what is the situation in the new process, right? Let's see what is the difference between the first process and the second process. In the second process, we have partitioned the job. We have given the initial job to someone who is not too expert, whose cost is a little bit cheap. She or he can do put these applications, which come in at rate of 1,000 per month, or if I divide it by 30, at 33.33333 per day. They come in. This first person immediately realized that 50% of these applications have no way to be accepted. They reject them, or claims or whatever, flow units. 50% of the flow units are immediately rejected. 25% are going to this process with a high probability of rejection, and 25% go to this process with the high probability of acceptance, correct? That is what we have. Out of this 25%, which goes through the process which has high probability of acceptance, 70% is accepted, 30% is rejected. Out of this 25%, only 10% is accepted and 90% is rejected. And then we have some inventories over there. In the first process, we have 200 flow units waiting. In the second, 25. In the third, 150. Now, what we want to do, we want to know how long does it take for an application to go from point A to point B. This is quite easy. This is just a straightforward applications of the Liddell's law. Throughput, we know what comes in, and we know what goes out. Throughput is 1,000 per month. We know that. Inventory, the total inventory inside the system is 200 plus 150 plus 25, which is 375. Agree? A total of 375 is our inventory. Throughput is 1,000 per month. We use the Liddell's law. We empty this process at rate of 1,000 per month, and all we have on average inside the process is 375. Apply the Liddell's law. And first of all, even before applying the Liddell's law, in the previous process, if we look, average inventory was 500. Throughput was the same as what it is here. In the new process, average inventory has come down. Therefore, even without computation, we can say that the flow time in the new system is lower than the flow time in the previous system, because R is the same for both of them, and I is smaller in the second alternative, right? However, if you want to go through computations, it is quite simple to compute it. 375 divided by 1,000 is 0.375 month, and if I assume that month is 30 days, if I multiply it, that is 11.25 days. So flow time was reduced from 15 to 11.25. Now let's go inside each of these subsystems and compute things like this. Compute flow time at initial review process, at subprocess A, at subprocess B, compute flow time of an accepted application, and compute flow time of a rejected application, right? We go through the first process. Throughput is 1,000, as we know. 200 applications are there. Simple application of the Liddell's law. 1,000 times flow time is equal to 200, and therefore flow time in the initial review process is 0.2 months, and if you multiply it by 30, it is 6 days. For sub-process A, 25% of the total applications go there because it is 1,000. 25% times 1,000 is 250. Throughput of that process, input, output, throughput is 250 per month. Average inventory is 25. We can just write the Lidl's law, and 25 divided by 250 gives us 0.1 month or 3 days. The same is true for the next process. 25% of 1,000 goes over there, which is 250. However, inventory in this one is quite high. In sub-process A, I had 25 units of inventory. In sub-process B, I have 150 inventory. That means sub-process B is quite slow. Indeed, without any computation, because throughput of both of them are 250, and flow time of the first one was 3 days, and inventory of this one is 6 times of the previous one. This one is 150, the previous one was 25. Therefore, flow time is 6 times of that, and that was 3. 3 times 6 is 18. But I can also apply the Lidl's law here. Inventory 150, throughput 250. Throughput times flow time is equal to inventory. You get 0.6 months. If you multiply it by 30, that would be 18 days. Okay, so I have all this information. Now I can look at this process from very macro level or from very micro level. Macro is to look at each of those 1,000 applications. Macro is look at them all, right? But I can a little bit come down, not very macro, a little bit macro, accepted and rejected. Come still down, not fully micro, a little bit micro. I can look at accepted through sub-process A, accepted through sub-process B, rejected through sub-process A, rejected through sub-process B, rejected initially. And I have all the information that I need. So I can look at accepted applications through these two routes. One is going through here, the other one is going through there. And then I can also look at the rejected applications. There are 3 routes. One route is initially from here, the other one is from here, and the third one is from there. Each of these routes can be computed. I have weight of each one, then I can weighted average them and compute the average flow time of accepted application and average flow time of a rejected application, right? Initial process 6 days, sub-process A 3 days, sub-process B 18 days. And I have the percentages. Now look at this graph. 25% go there, 70% accepted. 70% of 25% is 17.5%. And then 30% is rejected. 30% of 25% is 7.5%. Look at sub-process B. 25% go there. Out of that 25%, 10% is accepted. 10% of 25% is 2.5. The rest, 90% is accepted, is rejected. 90% of 25% is 22.5%. Now, fortunately, in this level, summation of these numbers, summation of these numbers is 100%. Summation of these numbers also is 100%, right? And of course, summation of these numbers are also 100%, right? Under the original situation, we had 15 days flow time. under the new situation, we had 11.25 as our flow time. But now let's look at flow times of accepted applications. Accepted applications, they may go through sub-process A, as we looked at here. If we go through sub-process A, (17.5% of applications, accepted application, go through here. 2.5 of accepted application go through there. So a total of 20% applications, 17.5% through this route, 2.5 through this route. I have the time of this route, I have the weight, I have the time of this route, I have the weight. Let me go to Excel and do a little bit computation. For accepted application, I can go through sub-process initial review plus A, initial review plus B. Initial review was 6, which is 6 here too. A was 3 and B was 18. If I add these things up, one route has 9 days, the other one has 24 days, right? But the one which has 9 days was 17.5%. So I'll go over there and I type 0.175. Then I go to the next one, and the next one was 2.5%. I go here and I type 0.025. Then now what I can do, I can say equal to this one multiply by this one, enter, and then I can say this one multiply by this one and enter. Or I can just take this one and copy it down. Then I can write equal to summation of these two numbers, which is this one. Alternatively, I could have said sum product of these two numbers, which were dates, multiplied by these two numbers, which are percentages, and I get the same number. These two are equal. But does a logical person can a logical person accept this 2.175? Of course not. How can average of 2 times, which one of them is 9 and the other one is 24, how can the average come out 2, right? So we have made a mistake somewhere. Where is it? Where is our mistake? If we look at our mistake is here. This is where our mistake is. Summation of these two numbers is not equal to 100%. When we do weighted average, we need to turn things into 100%. So what can I do? I go here and compute this summation equal to summation of these weights. Summation of these weights is 0.2, right? Therefore, this 0.2 should be translated into 100%. What I will do, I will come here and I say equal to 17.5 divided by 0.2 and lock it because I'm going to copy it down. This becomes 87%. And when I copy it down, it will become 12.5%. Now, if I add these two numbers together, summation is 1. I'm now correct. Then if I go here and say equal to sum product, I will get 9 and 24 multiplied by their weights, and I get these numbers, 10.875. Alternatively, I could have forgotten these two columns. I could have gone here again. I've said the same as before. This one multiplied by this one multiplied by this one, or just copy this one down. sum it up equal to sum this. Or alternatively, I could have said equal to sum product of these two numbers, comma, these two numbers to get the same thing. But the only thing I need to do is to divide this number by the summation of weights. If I do that, I will get the same thing because it will take it from 0.2 to 100%. So I got the same results as similar to if I have done this one divided by this and lock it and then copy it down and then equal to these numbers of these numbers and these numbers. Would have got the same result in both of them. Sum product of these numbers and the original percentages divided by sum of the weights. Exactly the same thing, right? Okay. As soon as I know that, computation for rejected application is quite straightforward because rejected application is the same thing. The only thing which is different are here. Again, some of the rejected applications go through initial review process and A, some of them go through initial review process and B, and some of them just go through initial review process, which is 6. And that is copy, paste, Ctrl V. So that is 6. Now if I go to my Excel sheet, if I look at it, rejected applications may go through this route, which is 50%. They may go through this route, which is 2.5%. Oh, I'm sorry. They may go through this route, which is 22.5%, or they may go through this route, which is 7.5. 50, 22.5, and 7.5. So I go back to my Excel sheet. Now the weights, here is 0.5. Here is 0.025. Seven and a half and 22. And if I add them up, it is 80%, the same as I had for rejected, right? Now all I need to do is equal to sum product of these numbers multiplied by these weights. But because summation of the weights is not equal to 100%, then I should again divide it by summation of these weights, which is 0.8, and therefore I get this number. Correct? So, while the average flow time was reduced from 1.5 to from 15, while the flow time was reduced from 15 days to 11.25. The good news is that flow time has even reduced more for accepted applications, and that is accepted applications which creates revenue into our organization. We inform them sooner and we get their money sooner. From 15 days, it was reduced to 10.875. Okay. The last thing I need to do, I know this is 8.75. I know it is 10.875. I put it into my Excel sheet, which is here, Control V. Okay. Now I have two numbers, 10.875, 11.438. How can I prove that these numbers are correct? How can I make sure that I didn't make any mistake in computation for accepted application and rejected application? I know that I have another number 2 here, and that is 11.25, correct? 11.25, copy. If I have not made a mistake, because this is 0.20% and that is 80%, if I have not made a mistake, then equal to sum product of these two numbers. Of these two numbers multiplied by these two numbers should come out what it is, right? What I computed at macro, right? So that is how I can make sure that my computation is correct.